All right, guys. So, what we're digging into today, tomorrow, and Thursday is solving. Digging into solving radical equations. And what we're looking at today, on the grand scheme of things, is actually not too involved in what we're doing. And a lot of what we'll be doing today is kind of revolving around this property, or this kind of property. Squaring each side of an equation. If two expressions are equal, then the squares are also equal. If a equals b, then a squared equals b squared. Well, if 2 equals 2, then 2 squared is equal to 2 squared. If they're already equal, if I square both sides, they're going to still be equal. They're still going to be the same. And we can use that to solve radical equations. Because what we want to do when solving radical equations is really first to get the radical by itself. The first main thing we want to do in solving radical equations is get the radical by itself. So looking at our first problem here, we have the square root of x plus 5 equals 13. Is the radical by itself? No. What is with it? Well, we have the 5, yes, because we have the square root of x plus 5. So to get the radical by itself, well, we need to subtract 5 from both sides. Well, 5 minus 5 is 0. Notice that the square root of x is equal to do we have the radical by itself? Is there anything else being added to that radical? No, because I don't have anything added here, do I? Is anything being multiplied by the radical? Or is it by itself? Yeah, because we just want the radical by itself. Now, what's inside the radical? Doesn't really matter. Because really what we are saying here, we have the square root of x. Kind of like if we had x squared. If we had x squared by itself, then we could square root both sides. Here, we want to get the radical by itself. Is how can I undo a square root? By squaring it. Because if I square a square root, the square root and square will cancel each other out. And what I do to one side, I have to do to the other. So once we get the radical by itself, we're going to put both sides to the nth power. We're going to put both sides to the nth power. Well, for here, we're not using the nth power, we're using the second, because we're dealing with a square root. If we had a cubed root, we wouldn't use squares, we would use cubes. We would use 3, because we're matching whatever the radical is. Now, the square root of x squared is x, yes? On the other side, we have 8 squared, which is 64. Do we need the plus or minus? No. We don't need the plus or minus. Because when we square rooted both sides, we added the plus or minus, yes? And that's dealing with the fact that what we have here, let's back up, I don't want that extra little mark. Here is we're starting out with the square root of x, yes? The numbers that come out of square roots have to be what? Positive, yes? So we know that whatever the square root of x is, it has to be positive 8. Well, the square root of 64 is 8, yes? So actually, I'm going to write this other one. Now, the square root of negative 64. Well, I can't take the square root of a negative number and get a real number. So we can't take the negative. We would get 8i. That doesn't work. Well, when we did take the plus or minus, we weren't looking at the square root of x. We were looking at what? X squared. Because with x squared, x could be positive or negative because of the properties of it being squared. That's the difference between these here. That's why we don't need the plus or minus. Because we're starting out with the square root of x, not x squared. Does that make sense? Because we're using a different property. We're using it the other way around. But that's it. That's all we have to do for this here. X squared. Because we're taking the square root. Because we're saying what times itself is, because if we are going the other way, we're saying that what times itself is 8. Here, we're saying 64, the square root of what number is 8. We're not seeing what number times itself. So we're going the other direction, so we only have one case. All right, let's look at this one here. I'm going to write it to the side, just so it's in the dead center. You can just work underneath the one you have. So our first step is to get the radical by itself, yes? What do we need to do first? We can do what? So we can add, but we wouldn't add the 3. We would, so we could add the square root of x, or we could subtract the 3. Oh, yeah. Subtract 3? Okay, let's subtract 3. And if we subtract 3 from both sides, we get that the negative square root of x is equal to negative 3. Is the square root by itself? No, we've got that negative out front. So what do we need to do to get rid of the negative? Yes, we can multiply both sides by negative 1, or we could do what? Divide both sides by negative 1. Because multiplying by 1 or dividing by 1 actually does the exact same thing. Doesn't change anything. Here we're just changing the signs from negative square root of x to positive square root of x. Here we'd have negative 3. Now it is positive 3. Is the radical by itself? Yeah, we don't have anything being multiplied in front of it anymore. We don't have anything added or subtracted outside of it. What's going on inside the radical really doesn't matter at this point. Because I could have 7x inside of that radical. But we're mainly just focused on the radical itself. Is it by itself? Well, yes. So we're going to put both sides to the nth power. Well, since we're dealing with a radical, the square root, since we're dealing with a square root, we're going to put both sides to the second power. And the reason we're doing this is because, well, the square root of x squared is x. 3 squared is 9. And that's it. Any questions on this here? All right. Let's look at this one here. So our first step, get the radical by itself. Is it by itself? Yeah. Okay, put both sides to the nth power. So we're putting both sides to what? Second, because we're still dealing with square roots. So the square root of x squared is x. 6 squared is so really we're just trying to figure out what is the number that when multiplied by itself gave us 6. 36. I know we're going the other way around because when we talk about x squared equals 36, we're trying to find out what number times itself is 36. 6 times itself is what number is the way we're going with these here. Well, and it does say check our solution because we could just plug it back in and say the square root of 36 is 6. It works. How about this one here? What would we do first? We would need to add 7. We need the radical by itself. We need to add 7 to both sides. Because negative 7 plus 7 will cancel out, telling us that the square root of x is equal to square root of both sides, exactly, so x is equal to 100. And then we could plug it back in to make sure that this is correct, and yes, it would be. We could say that the square root of 100 minus 7 is equal to 3. Square root of 100 is 10, and 10 minus 7 is indeed 3. So the correct answer is 100. Any questions on this here? Okay, let's go on and look at the next one. Yeah. Let's go on and skip to this one here because I feel like y'all have got a decent handle on these here. These simple 1-2 steps. Solving this equation here. So again, our steps are really not going to change, except it would be good to add step number 3, which is check. We just need to make sure to check, especially when we have addition and subtraction inside the radical. Now looking at this here, the first step is to get the radical by itself. Well, as we see this here, the radical is not by itself. So what do we need to do first? We'll subtract 3 first, because it's going to be, most of the time, it's going to be easier to do the addition subtraction first before we do the multiplication or division. And if we subtract 3 from both sides, 3 minus 3 is going to give us 0, leaving us with 4 times the square root of x plus 2 is equal to 16. Is the radical by itself? What do we need to do next? We need to divide both sides by 4. Because here, 4 divided by 4 is 1. Yes? I think you're giving me the answer for the other side. Because 16 divided by 4 is indeed 4. Is the radical by itself? Yes. Because we do have the x plus 2, yes? But it's still a part of the radical. Because what we're also saying, square root of x plus 2, yes? If we wrote this as a fractional exponent, it'd be x plus 2 to the 1/2 is equal to 4, yes? So the x plus 2, that whole thing is connected to the 1/2. So here, if I want to simplify the 1/2, I would use a multiplication of 2, because powers and powers multiply. So we would apply 2 to both sides. Here, we would be squaring both sides. Because what we're doing for either one of these is the exact same. Because we're very used to, and it's kind of nice, easy shortcut to say, okay, when we square a radical, they cancel out. But realistically, what we're saying is we have x plus 2 to the 1/2 squared. And our 1/2 times 2 is just 1. So we're just saying x plus 2 is equal to . That's why this worked. That's why this is so nice. Well, we need to solve. We need to subtract 2. Telling us x is equal to 14. So really looking at this here, check isn't really step 3. Step 3 should be solve. Step 4 is check. Because here, x equals 14, that's fine. But we do need to make sure that if we plugged it back into the original statement, we do get the correct answer. So what we're saying is 4 times the square root of, not 16, it was 14 plus 2. Plus 3 equals 19. And again, at this point here, especially if it says to check on the test, you're not going to have to walk it all the way through. It's really, we set it up like this here. I can type this into the calculator. Okay, it says 19 is equal to 19. It checks out. We're good. And again, on the check steps, that's really all you have to do to show that it does check, that it does work. And you might be thinking, well, couldn't we just plug in whatever number and say, hey, it equals the same thing? Well, yeah. But if you got the wrong answer here, and you just said 19 equals 19, it's kind of obvious you didn't actually check it. So there is that. But the checking step does help you, especially when you're solving these, to make sure, hey, did I get the right answer? Any questions on these here? We ready for the next one? Okay. What do we need to do for this one here? Yeah, we need to add 1. We need to get the radical by itself. So we would add 1 to both sides, which will tell us that's 3. 3 times the square root of . Right, the radical is not by itself yet, so we would divide by 3, telling us that the square root of x plus 5 . Any questions on this here so far, how we got the radical by itself? Then we would square both sides. Square root and square would cancel, telling us that x plus 5 is equal to 16. And last but not least, to solve for x, we would subtract 5 from both sides, telling us x is equal to 11. And again, if we check this here, we will see that this is the correct answer. Any questions on these here? Do we feel comfortable with these here? Yes? Yara's a bit bored? No, you're fine. I think he or reads ahead of you. Any questions on these here? All right, let's go on and look at the next type. Let's look at example 3. So Okay. So if we look at the steps that we have, one, get the radical by itself. Well, we have more than one radical, don't we? So let's add a little subclause. If more than one radical even them out. If there's more than one radical, even them out. If there's more than one radical, we want to even them out as best we can. So if there's two, we want one on either side. If there's three, well, we can't really even them out as much, so I do 2 and 1. Or if there's 4, we're going to do 2 and 2. We want an even number on either side as best we can so that they're easier to work with. Okay? And then try to get them as by themselves as we possibly can. Because when we get into Thursday, we're going to start looking at some of those cases where we can't really even them out too well and see how those work. But here, okay, we've got them as even as we can, yes? Well, okay, let's go on and put both sides to the nth power. So here we're going to put both sides to the second power. Well, square root and square will cancel each other out, leaving us 2x minus 1 is equal to, well, these will. Solve. Questions on this here? Yes, we can subtract x from both sides. Well, 2x minus x is x. And we have our minus 1 is equal to 4. At this point here we can add 1 to both sides, telling us x is equal to 5. Now again, we can check to make sure that we do have the correct answer. Because we can say 2 times 5 minus 1 and compare it to square root of 5 plus 4. Well, 2 times 5 is 10, and 10 minus 1 is 9. Square root of 5 plus 4 is 9, yes? Are they the same? Is the square root of 9 the same thing as the square root of 9? Yeah, okay. It works. I don't have to take the square root of both of them, because since they both have the radical, okay, they are the same. Square root of 9 is the same thing as square root of 9. And this is handy, especially if whatever we're taking the square root of, we can't actually take the square root of nicely. Because if it had been, say, the square root of 7, square root of 7 is the same as the square root of 7. I don't have to turn it into a decimal. We know those are the same. And the main reason we would check is because, again, we said we can't take the even root of what? A negative number. So even if both of them are negative, negative 9 and negative 9, it doesn't work because we cannot have a radical of a negative. Any other questions on these? Because I feel like doing more of this isn't going to help. Yes. The next one? Yes, it would be harder. Because, and that's a great, this is why I put this one in here. I put this one in here just for that case, because we could square both sides as it is right now. If we did that, what would we get here would have the square root of 3x plus 1 minus the square root of 4x minus 7 times the square root of 3x plus 1 minus square root of, because if we squared it as it is right now, when I square that set there, we're multiplying it by itself. Now it's worked out nicely on the other ones because when I squared this here, there's only one thing. I'm just multiplying it by itself. I don't have to do this distributive property. Here, we have two things that are being multiplied by themselves, yes? Let's not do that. So, we can add the square root of 4x minus 7 to both sides. And that's why we put that little subclause, that's why I put that there. If there's more than one radical, let's try to even them out. So here we can get one on either side. Now for us, those cancel out, leaving us with the square root of 3x plus 1 is equal to square root of positive 4x minus 7. And now, since we only have one of them on either side, we can square both sides. Here, square and square will cancel, telling us that we have 3x plus 1 is equal to, here the square root and square will cancel, telling us that we have 4x minus 7. And then we can do what? Subtract 3x, because at this point we're just solving for x. Subtract 3x from both sides. Those will cancel, telling us we have 1 is equal to x minus 7. Then we can add 7, telling us x is equal to, and again at this point here we can plug it back into the original equation to make sure that that does work. And for this here we really don't have any negatives that could possibly come up. And all I'm saying is when we look back at this here, 3x plus 1, 3 times 8 plus 1 is really not going to give us a negative number. The same is true for 4x minus 7. So we could say 3 times 8 plus 1 minus 4 times 8 minus 7. 3 times 8 is 24 plus 1 is 25. 4 times 8 is 32. Minus 7 is again 25. Is the square root of 25 minus the square root of 25 equal to 0? Yep. So it works. Any questions on these here? Let's see what's next. Well, that's the exact same thing, yes? So we can square both sides, telling us that n is equal to 5n minus 1, yes? Then we would what? Subtract 5n, which would tell us that negative 4n is equal to, divide by negative 4. And if we plugged it back in, we would get that they're the same. Because 1/4 times 5 is 5/4. And if we take 1 away from it, we'd be left with 1/4. It'd be 1/4. So that'd be 5/4 minus 4/4, which is okay. This one looks different, yes? Because we don't have a square root, we have a, okay. Let's just check our steps that we have. So 1, get the radical by itself. If there's more than one radical, even them out. Well, we only have one radical, yes? Step 2, put both sides to the second power, yes? No, it says both sides to the what? Nth power. So this time we wouldn't use square, we're going to use cubed. So here we can cube both sides. Because again, just like with square roots, the cubed root cubed, these here would cancel out, telling us that we have 5x minus 2 is equal to, it's going to be big, 1,728. Solve. We would. Add 2 to both sides. Tells us that 5x is equal to 1,730. That's it. So even if we have a cubed root, is it doing anything different? No, we're doing the exact same thing, except instead of squaring both sides, we are cubing both sides. Any questions on this here? That's not any different. We're just cubing. What would we do for this one here? We would add 4. I'd start off by adding 4 to both sides, which will just tell us that the cubed root of y is 5. Then we would cube both sides. Now with odd roots, the number inside of it can be negative, because we can take the negative, the cubed root, or the odd root of a negative number. That's fine. Any other questions on these here? We like these? And that's it. There are 15 problems attached with this here, but as y'all have seen with most of these here, it doesn't take too long to work through them. What we'll be dealing with or digging into tomorrow and Thursday is some of the other cases where we don't have them work out nicely, especially if we have solutions that don't work.